Okay, class. Okay, so now we are in example 2. Okay, so it's in this example. Okay, we have a balanced three-phase Y connected generator. Okay, with positive sequence, which is connected to the Y load connected. Okay, as shown in the figure. Okay, so the load impedance, okay, of 39 plus J ohms per phase, okay, we have in this figure also. Okay, and then the impedance of the transmission line connecting to the generator to the load, okay, is 1 plus J 2 ohm per phase. Okay, and the R phase generator voltage, okay, which is ERN, is specified as the reference phasor. Okay, the question asks you, okay, to construct a single phase equivalent circuit in the system, okay, to calculate the three-phase line currents IRR, IYY, IBB, and the return current I and N. Okay, you are also have to calculate, okay, three-phase voltages at the load VRN, VYN, and VBN. Okay, you also have to find, okay, the three line voltages at the terminal of the load VRY, VYB, and VBR. Okay, and you have to calculate the apparent power, active power, reactive power at the single load. Okay, and you also have to calculate the three-phase apparent power, active power, and reactive power at the load. And finally, you have to draw the phasor diagram to show all voltages and currents at the load. Okay, so in first place, okay, you have to construct the single phase equivalent circuit of the system, okay, which using the VRN as your reference. Okay, so based on this, okay, three-phase balance system, okay, Y to Y connection, okay, with the consideration, okay, of the line impedance here, okay, so we just some sort at you cut, okay, this phase R, okay, to get your single phase equivalent circuits. Okay, so luckily, okay, your load, okay, are already in star connection, okay, and your generator also are in star connection. So you don't need, okay, to do any conversion, okay, for the load to put, okay, in a single phase equivalent circuit. Okay, so you just take 39 plus J 28 ohms. Okay, and the line voltage is 1 plus J 2 ohms, and the generator, okay, generator phase voltage, okay, your ERN, okay, is taking as 240 0 dp as your reference for the R phase, okay, for the R phase circuits. Okay, so the next, okay, after, okay, construct the single phase, okay, so now, okay, we calculate the line currents. The line currents is the current that flowing through your, okay, through your lines here from your generator to your load. Okay, so for this, okay, type of questions, okay, so you have to consider the transmission line here, transmission line impedance here, okay, so which is given as 1 plus J 2 ohms. Okay, so we know that, okay, in star connected system, your I phase is equivalent to I line. So means here, okay, you have to find only your whether your IRN or, okay, you just, okay, find your IRN. Your IRN is your phase current. Okay, so definitely you will get your I line, IRR here. Okay, since, okay, I repeat again, since, okay, there are in this circuit are in Y connected. Okay, so your IRN, okay, if you base it on your single phase equivalent circuit here, okay, so your I phase, okay, which is, okay, the current through this phase, okay, in series, right? Okay, so is equivalent to 240 divided by the summation of the total impedance here. The total impedance is Z line plus with your Z load. Okay, which give you, okay, the current is at 4.8 with minus 36.87 degree ampere. Okay, so since again the condition are in balanced load condition, okay, so the current have the same magnitude, okay, with the phase difference between each other is about 120 degree. So hence here, since again we follow the RYB sequence, okay, you just need to add additional by minus 130 degree or minus 240 degree or plus 130 degree respectively from your reference, which is the angle at IRN. Okay, so we look here. Okay, so your IYY is equal to IYN. Okay, so IRN is your reference current. Okay, so they are same in magnitude, right? So the magnitude is still 4.8. Okay, but the angle, okay, so you have to add the angle at your IRN by another minus 120 degree because we follow the RYB sequence. Okay, so you have the IYY or IYN is equal to 4.8 with minus 156.87 degree ampere. Okay, while for your IBB or IBN, okay, it's the same, right? The I phase is the same with the I current for the Y connected. Okay, so they're sharing the same magnitude as what you got in your IRN. Okay, but the angle now, okay, so you have to add either with plus 120, okay, or minus 240. Okay, the position is the same. Okay, position. Okay. All right. So if you are taking IBB by additional angle of plus 120 as referred to your IRN, so you will get your IBB is 4.8 with plus 83.13 degree ampere. Okay, but if you are taking the angles by the additional of minus 240 with your IRN, so you will get 4.8 and the angle is minus 276.86 degree ampere. Okay, for the I neutral or return current INN, we can get from the summation of IRR, IYY plus IBB. Okay, so you sum all these three currents, and finally you should have, if the system are in balance condition, okay, so you will have your I neutral is 0 ampere. Okay, so the next question is to find the phase voltages at load, which are VRN, VYN, and VBN. Okay, so we know that your V is equal to I times with your Z. Okay, so your VRN is equivalent to IRN times with your ZRN. Okay, so all the V, so you multiply with the respective Z. Okay, so for your VRN is 4.8, with minus 36.87 degree angles, times with your ZRN 39 plus J 28. So the answer is 230.44 with minus 1.19 degree. Okay, so if we use the statement which for the balance condition, the same magnitude are sharing between the phase voltages, but there are differ each other by 120. So we just do some working on the angles. So some changes on the angle. So VYN is 240 230.44, okay, with the angle minus 1.19, okay. So you minus with 120, okay, as you refer to the VRN angles. So you will get 230.44, okay, the angle is minus 121.9 degree angles. For your VBN, okay, so the magnitude, okay, still the same magnitude, okay. So 230.44, okay, and the angle now is, okay, either you want, okay, either you want to take, okay, the angle with the additional of 120 degree with your reference VRN angles, or you want to take minus 240 degree, okay, as referred to your VRN. Okay, so these two position, okay, which is 230.44 with 118.81 degree both, and 230.44 with minus 241.19 degree. Okay, so these 2 points, okay, is the same in position. Okay, so